in our earlier videos, we had already discussed about what is polynomial regression and why we use the polynomial regression and what are the uses and advantages of the polynomial regression. So, in statistics, the regression analysis, it is very helpful. Is a very helpful statistical tool for studying the correlation between two sets of events or variables between a dependent variable and one or more independent variables. For example, your weight loss, that is a dependent variable, depends on the number of hours you spend in the gym. That is, those are the independent variables. So, like this, the correlation between the two variables or two or more variables we will study in the regression analysis. So, as we know that in regression analysis, we use for to check the relation between two or more independent and independent variables. So, there is a one dependent variable and two or more independent variables. So, the hours you spend in the gym, and other variable factors are involved in this analysis. That analysis we can say it as a regression analysis. So in regression, we are having linear regression, multiple linear regression, and logistic regression, and polynomial regression. About simple linear, multiple, and logistic regressions, we already have some other videos about that. And the simple linear regression means in this regression model, it allows you to estimate the linear correlation between two variables. Only two variables will be there, one dependent variable and another independent variable. So, the same example what we had studied, the more time you spend on your physical activity and the bigger your weight loss is. So, there is a linear correlation here. So, in the linear correlation graph, if you see and you will understood that there is a straight fit line will be there, and through that we can predict the y dependent variable. So that is the simple linear regression. Whereas in multiple linear regression, it is related to simple linear regression only, but instead of showing the correlation between just one dependent and one independent variable, you can consider several independent variables. Only one dependent variable will be there and several independent variables are there, then we can say it as a multiple linear regression. For example, you can consider hours at the gym and daily sugar intake and calories you consume to predict your weight loss. So these are all will come under multiple linear regression. So and the next one is the logistic regression. Logistic regression means we already know that it is also one of the type of regression analysis. In this logistic regression, we can study about in this logistic regression, we can analyze the data sets in which there are one or more independent variables that determine the outcome of categorical dependent variable. And it is primarily used for binary classification problems like we know that true or false, 0 and 1, yes or no type, where the dependent variable has two possible outcomes. We can say it as a 0 and 1. There is a two possible outcomes. That time we can use the logistic regression. So it can also be handled by with multi-class classification problems also we can use. So in the logistic regression, dependent variable, this is the response variable in that, is a categorical and represents the outcomes, and it is typically like a binary such as yes or no, pass or fail, or 1 or 0. Like that we will represent for the dependent variable. And the independent variables in the logistic regression are predictors. Like this logistic regression can involve one or more independent variables. We can say it as a features or predictors. So those are used to predict the probability of a particular outcome for the dependent variable. For the response variable, we are having some predictors or future features. So these independent variables can be continuous or categorical. That time we can definitely follow this logistic regression. And we can follow the sigmoid function for to do the logistic regression analysis, and based on that we can when you are using the sigmoid or logistic function, and that is an S-shaped curve. That's an S-shaped curve. This function maps the log odds to range between 0 and 1, representing for the probabilities. So that like that we can check, and we can check the maximum likelihood estimation also in the logistic regression, and which curve having the most maximum likelihood estimation, then we will choose that curve for the prediction. So means in this we will choose some parameters like some coefficients of the model using maximum likelihood estimation approach. So the main aim of using this approach is to find the parameter values that maximize the likelihood of the observed data as per the data given. And also we can check the threshold values, and we can evaluate the metrics also. So this logistic regression, it is widely used in various fields including like healthcare for predicting disease outcomes, and for marketing, and many other areas where this binary or multi-class classification is useful. And this and the next we'll see about polynomial regression. So polynomial regression is also one of the regression analysis, as we know. The polynomial regression, in this we will study about the modeling the relationship between the dependent variable and one or more independent variables will be there in the polynomial. And when the relationship is not linear but can be better approximated by a polynomial function. So we are already clear about that. So the polynomial regression, we'll see. Here we can see that the polynomial regression. So in this also we can use one dependent variable and one or more independent variables, but when there is no relationship bit and the relationship is not a linear but can be better approximated by using the polynomial function. So in it is like extends to the linear regression by allowing for more complex curved or nonlinear patterns for the data. So in the polynomial function we use this function for a specified degree. It is used to represent the relationship between the variables. So the form is like this. We know that y equal to b0 plus b1 into independent variables, but b2 into x1 square another independent variable, and so on the nth degree value. Till the nth degree value we will select in the polynomial regression equation. As we know, y is the dependent variable and x mentioning is the independent variables, and beta 0, beta 1 and beta n are the coefficients to be estimated, and so on. N is the degree of the polynomial which determines the highest power of x included in that equation. So what is this degree of polynomial? Means the choice of the polynomial degree is very important. A higher degree, it allows the model to fit the data more closely but cannot lead to overfitting. So this model captures noise in the data rather than underlying pattern. So a lower degree may oversimplify the relationship. And in this polynomial regression, we need to check the curve fitting also. So how curve fitting means? It can capture a wide range of non-linear relationships, including U-shaped curve, inverted U-shapes, and more. So by adjusting these degree of the polynomials, we can control the complexity of the curve. And also in the function we had already seen about the coefficients. The coefficients like beta 0, beta 1 and beta n. So these polynomial regression estimates the coefficients like linear regression only by using the methods like least squares which minimize the sum of square differences between the observed and predicted values. And next, we will do the model evaluation in the polynomial function. Model performance is assessed using metrics like mean squared, MSE or R squared or other appropriate measures. And also cross validation can also help to determine the optimal degree of the polynomial. So like this, we will do by using that polynomial function, we can check the analysis. So this is polynomial regression is very useful when the relationships in the data are not adequately described by the linear models. And there is a higher degree polynomials can introduce the complexity and may lead to overfitting. So particularly if you don't have the large amount of data. So this is a very versatile tool for capturing non-linear relationships and can be applied in various fields like in physics, biology, economics and engineering. So for the complex patterns, it's very essential, this polynomial regression. So this is about just introduction and about the how we use the function, and for the complex problems how we can use this polynomial function, and the polynomial function problem also just simply explained in the earlier videos. And today also we'll see one other example about polynomial regression. And we had already learned about what are the advantages of polynomial regression also. And so mainly we had already understood about why we need this polynomial regression also. And so based on the data sets and the situation on which data set you are working, this method can be useful for the more complex type of problems. And this can be applied when simple linear regression underfits the data. When the simple linear regression is underfits according to the given data, that time also we can use this polynomial regression. And the advantages also, we had seen that it is a non-linear relationship between the variables, and there is large range of different functions that you can use for fitting in this polynomial function. And where we can use this polynomial regression also, we had already seen for the death rate prediction and also like speed regulation software like that. In those areas also we had already learned about how to use this polynomial regression. And now let us see one example about polynomial regression. And we can see here underfitting and just right about the curve fitting and overfitting. So like this you can see. So in this type of situations, you can definitely use this polynomial regression. And next here, we'll see one example about polynomial regression. Yield data set we have the data set of size n equal to 15. So this is the yield data, contains measurements of yield from an experiment. Then at 5 different temperature levels, the variables are y equal to yield and x equal to temperature in degrees Fahrenheit. The table below gives the data used for this analysis. So here we can see the table, and these are the serial numbers, and these are the temperature values. We can denote it as x, and yield values we can denote it as y. So like this we have the data, and according to that we are having one diagram about to check this, like this is like a scatter plot of the raw data, and then another scatter plot with a linear pertaining to a linear fit and quadratic fit overlaid. So the trend of this data is better suited to a quadratic fit. You can see that the fitted line plots according to the given data of the temperature and the yields. Here we can see the fitted line plots that y equal to 2.306 plus the temperature we got according to the given mentioned here. And fitted line plot for the field of this, we can see fitted line plot for the yield 7.960 minus the temperature value 0.1537. We'll get the values. So based on these scatter plots of the given data, so and another scat plot with lines pertaining to a linear fit and a quadratic fit overlaid. So and this trend of the given data is better suited to a quadratic fit. So like this, we need to check as per the given data how the regression that line was fit. And next here we are having the linear fit results like regression analysis for the yield and for the temperature. So we need to calculate those values of R square and R square adjusted and R square predicted, and also we need to find out the coefficients also, coefficients for the constant coefficients and the, according to the given temperature coefficients, and use the regression equation y equal to yield equal to 2.306 plus 0. The given temperature, and we have the quadratic fit results. So based on that, the polynomial regression analysis, based on that we can get the values of S value, R square and R square predicted values also we can get by doing the calculation, and we need to find out the coefficients also. Then use these values in the regression equation y equal to the given values and the temperature and the values. So we can see that both temperature and temperature squared are significant predictors for the quadratic model by using the p values of 0.0009 and 0.0006, and then that fit is much better than the linear fit. So we had seen the quadratic fits and linear fit. Here we can see the this polynomial regression analysis for the linear fit and the quadratic fit. According to that, we can understood that based on the data, it is much better than the linear fit. So from this output, we can see the estimated regression equation y equal to 7.96 minus 0.1537 and the temperature values into temperature given according to the given independent variables. And also based on the ANOVA table also we can the model we fit the statistical significance at the 0.05 level. Here you can see the model fit is fitted at the 0.05 level. With the p-value of 0.001. With the p-value of 0.001 and the statistical significant at the 0.5. So like this, we need to check all the values according to the given set of data. Based on the data, we need to check first the regression model consisting of like the best fit line, the quadratic or linear fit, that we need to check, and we need to find out the R square and the R square adjusted values and also coefficients values also. And next we need to model that summary values like the square of height, according to the given data, we need to do the statistical analysis and finding the coefficients of the values. Then we can check the which value is more significant. So like that we can understood which value, which analysis is far more better than the given data. So like this polynomial regression analysis we can check to calculate. So finally we can conclude that this polynomial regression is One of the statistical method, we can use this function with higher exponent to form more complex form. When the data is more complex, that time you'll definitely use this. Then the simple and the multiple linear regressions are perfectly fine models, but not fit for all use cases. So, according to the given explanation, we can understood that when the data is more complex and when the data is not fit according to the given analysis, that time also we will definitely use this polynomial regression analysis. And the real life examples also we had already seen about the polynomial regression analysis. So the real life examples we can already checked about medical research field and the environmental science and in the marketing and sales, and for the forecasting in the environment also, like the relationship between the factors like GDP growth and unemployed rates. For this type of analysis also this polynomial regression can be applied. And also for the stock market analysis also we will use this polynomial regression analysis for to analyze the stock prices over the time. And this polynomial regression can help identify the trends and they can predict the future prices more accurately than the linear models. And also in the medical research, we can use to study the dose response relationship to for drugs or for the treatments. So we can check the optimal dosage by modeling how the response variable changes with the increasing doses. And also in the environmental science also we can use this. And the physics also we can use this polynomial regression, like for the experimental data. It can be used to model the behavior of materials under stress, and there we can check the relationship between stress and strain is non-linear. Like this also in physics also we are using. And for the climate science also we can use to analyze the temperature data and assess the presence of long term climate trends, like for that also we can use. And in engineering also we are using the polynomial regression to analyze stress strain relationship materials testing. And in education also using the polynomial regression to study the relationship between study time and exam scores, like that. And in the manufacturing industries also this analysis is very useful to optimize the process, like determining the ideal temperature and pressure conditions for a chemical reaction, and also for finding the optimal production speed for a manufacturing line. Like this in so many areas, some of the examples only I had told. In so many areas we are following the polynomial regression. It allows analysts and researchers to model complex and non-linear relationships between the variables, and also providing valuable insights and improving the predictive accuracy also. So, however, it's very essential to choose an appropriate polynomial degree to avoid overfitting, and we can ensure that the model generalizes as well as the given data or for the coming new data also. So, this is about polynomial regression. And as of now, we had already we discussed about what is regression and what are the kinds of regression and how we can do the regression analysis, and what are the kinds of regressions: linear, multiple linear regression, logistic regression, and polynomial regression with examples and with real life examples also. We had already done about this regression analysis.